Hello, welcome everyone. Today we'll be talking about the cleanroom monitoring and the reason that we're using monitoring systems in our cleanrooms, especially with the particle monitoring systems. But we will be also mentioning microbiological activities, especially with the active sampling technologies, and how, when, and why we do the monitoring in our cleanrooms. Before we start, let me introduce myself. My name is Hashim Solmaz, and I'm the General Manager of Lighthouse Worldwide Solutions EMEA Operations. And I'm also serving to the ISO TC209 as a Head of Delegates and the subject matter experts in Working Group number 2 in Biocontamination Control, Working Group number 3, Cleanroom Test Methods, and Working Group number 15, which recently formed Airborne Particle Sampling Techniques, which will also include today's subject, especially for the monitoring systems. Once required, I will be giving you information about these sampling techniques as well. So there are some other responsibilities that I have in different non-profit organizations, and currently I'm also the faculty member of IEST, which is Institute of Environmental Science and Technology in the US, as a Contamination Control Institute faculty. So we will be starting with the monitoring plan, especially for the particle monitoring systems, and how to create and how to implement and how to maintain these infrastructures. First, monitoring according to ISO 14644-2, observations made by measurements in accordance with a defined method and plan to provide evidence of the performance of an installation or the overall system performance that we can mention. So first of all, we have to design our monitoring system, which will be aligned with the entire monitoring solution. The next step will be specify the requirements, the locations, and the system overall performance, including the operators and materials flow. And we will be executing our plan by installing our monitoring system into the final locations. And once we finalize this installation, we will be doing our qualification in order to ensure that our system specification meets all the criteria on our design as well as intended use of the system. After that, we will start doing our monitoring by collecting data, which will be giving us the early definitions of the system integration, plus if there are any issues or evidences that we need to perform testing for the system overall performance. So output of this monitoring system is in general the alarms that we are generating through the system, not only in the documentation side, but also during processes, during operation. We also warn our operators and the system in order to get these feedback as soon as possible so that operators can easily control the things which is out of limit. So monitoring plan defined in 7 easy steps in ISO 14644-2. This is also the same requirement for all other international regulations such as GMP or FDA. So first, we need to prepare our monitoring plan. There should be a written monitoring plan that we developed. We need to review and approve with different stakeholders of our organization, not limited with the quality department for sure. There should be a contribution from engineering, from production, from qualification department, aligning with our classification data, for example, when we're talking about particle monitoring systems. Implementing the plan by performing the monitoring and then analyzing the data derived from the monitoring activity, undertake trend analysis where appropriate, and we need to make sure that these trend analyses are giving us, even we are within the limits, they will be giving us the early flags that are having an issue with our system, if there is a problem in the monitoring data, or if it is going out of the limits with a certain slope, so that we will be able to make a predictive maintenance on our system. Number 5 is the reporting our performance with the documentation. Number 6, we have to implement and document actions or corrective actions if required after collecting all this information. This is not always parallel with the data that we collect from field, because sometimes our operators are taking necessary action in order to fulfill requirement. But in any case, reason has to be investigated with these corrective actions. Number 7 is to undertake periodic review of our monitoring plan. Unfortunately, most of the monitoring plans that are in place in most of our clean rooms never been reviewed during the process. And we have been seeing this problem in many locations. Even the structure in our clean room changes and the new issues are in place. We're not really making the update on our monitoring plan so that the results are not always matching the final requirements from our clean room. For example, you have a certain device in your clean room where you get in count for the monitoring plan. But in the long run, you have additional equipment or additional processes that you include into your system. However, your monitoring plan is representing that where you stay, where you started, and as of today, it's not really representing the final situation of your clean room. That's why we have to take these periodic review sessions at least once in every year, so that we need to make sure that the site is represented by these monitoring plans. Next one, the matters that we need to consider during developing these monitoring plans. There are 11 easy steps that are derived from the standard itself. One, we need to select the parameters to be monitored. In our case, for clean rooms, we are monitoring 0.5 and 5 micron particle sizes. Still, even if it is out of ISO for classification, still for monitoring in GMP, also for ISO, we are using 0.5 and 5 micron particles, because 5 micron is a critical indicator of early HVAC system failure. That's why 0.5 and 5 micron for number 1, which is our parameters for particle monitoring systems. You can still add 1 micron, which means 0.5, 1 and 5 micron, in order to align this data with your classification with 0.5 and 1 micron. So if you have these feature on your system, monitoring system, try to collect 0.5, 1 and 5 micron together. Number 2, select measurement method. So we will be using particle counters, which is airborne particle counts with the laser-based devices, so that we will be installing them. Number 3, monitoring instrumentation. Their accuracy, maintenance, and calibration is critical. I will be giving you a couple of examples, but here, in order to maintain your system, you have to consider the locations, the final locations that you installed your particle counter. Not only isokinetic probe, where you take the sample from the sterile area or within any clean room locations, but also location of your particle counter is critical, because in order to maintain the entire system, you have to make sure that the device is accessible for this maintenance, for servicing, and for calibration as well. So monitoring locations, better to define in 3-dimensional diagram, because it will be showing you the final location from up to down, also from the level as a height of your location. For example, if you are sampling the vial filling line, each and every vials that you will be filling in this line has to be considered. That's why thinking in 3-dimensional is critical in order to develop the right monitoring plan. Number 5, monitoring acceptance criteria and limits. Without these limits and acceptance criteria, without the alarm limits, for example, collecting all this data will not be useful for monitoring purpose, only for documentation. Reason here, we're not able to generate these alarms so that operators can interfere during this production. And out of limits and criteria, what will be your response? How you will be responding into these locations? You have to make this within the limits, as well as the critic level. For example, if it is within the sterile area, your action will be different. Or if it's outside of your clean room, which is grade C for a partially sterilized product, your action will be different. So you have to define the level of criticalness as well as the way you will be responding to this action. So it has to be written in your monitoring plan. So there is a need for the frequency of periodic cleanroom classification, which the data you will be collecting according to ISO 14644-1 will be also giving you the evidence for the location of sampling, duration of sampling, and the limits that you will be defining for the certain location. Number 8 is about the format. The format that we use will be the data recording and our trend analysis, so that this data will be collected on our database, which is a secure database, and the software, which will be suitable for example, 21 CFR Part 11 compliant software, which is validated, so that you will be reaching out this data anytime you want. And you will be make sure that the data format as well as the data numbers will not be changed by the operators, or the third-party intervention will not be possible for this kind of protected database. The methods for data trending and other appropriate analysis will be generating our method, so that after collecting this data, year over year or week over week or even batch over batch, you'll be able to see and compare the data that you collect from the field. And the policy and the media, where you're going to record this data, how you will be taking the recovery action if anything happens, or how you will be recording the data outside of your premises, so that if you lose your data with any reason from your server, how you will be mitigate this risk from this location. So it has to be written on your monitoring plan as well. And number 11, again, the frequency of the reviewing your monitoring plan has to be mentioned. If you are going to make it in quarterly basis, every 3 months, you have to mention it, and who will be responsible, who will be the stakeholders for this monitoring plan review. Next one is the Cleanroom Monitoring System application, how we will be designing it and how we will be implementing it into our final location. For example, let's think about the designing a monitoring system for filling line. This will be a vial filling line where we have a turntable here, and this turntable moving forward directly to the filling needles. And after that, we have a stoppers, which is a semi-stopper, because our process will also include the lyophilization process. So outside of this line, the product will go directly to the lyophilization line, so that we will be considering each and every location as a risk location. But keep in mind, when you know how you will be representing your locations, you have to make sure that starting from your depyronization tunnel, all these area that I mentioned on my drawing is our risk locations. Reason I'm saying, because we know that the turntable is turning counterclockwise, so that it collects all the samples and allocate them directly into this line, so that they're going one by one into the filling needle. So other side of this turntable, for example, is not as critical as the side that we are dealing with. Reason here, all the operator interventions, all the gloves are on this side for this wrap system. So we know that the process will be maintained from this side of the operation, so that my risk location for the turntable starts as it is, and then the star wheel takes all the vials to the filling line, then the stoppers put the semi-stopper, again the star wheels here takes the unit and send it directly to the either lyophilization process, or if it's a completely stoppered product, it will be going to the capping station. So if you know the process very well, then you will be able to define your risk level and your risk locations. Let's take a look at it one by one. For example, starting with the turntable. In this turntable location, my risk area is in this location, right? So the best approach could be placing here, you can see my while sampling, the particle sampling is in this location. However, I can place it into the corner here because I will be able to access this location, and according to FDA's aseptic processing guideline, 1 foot 30 centimeter away from my sampling location gives me the risk area. So since I will be collecting these items one by one into these line, so that having these particle counter in this corner is a good approach. But take a look at the mock-up study from this location. So what we did so far, we know that the handles that we will be using this location at this corner is quite critical. And my plan, my initial plan from the beginning, if you go back, I was planning to put my microbiological sampling heads right in this corner. However, there will be one handle where I will be able to reach out to the product. But for microbiological sampling, I need my 2 hands will be accessible with these gloves because I'll be taking out this impactor head, placing it one location. I'll be taking the entire agar plate in my hand, on my left hand, for example, then my right hand will be opening the lid. So I'll be placing the lid in one location. So 2 hands operation is critical. That's why I will be allocating this corner for my microbiological sampling activities. So let's take a look at it again from this image here. I will be placing my particle counter in this location so that this area will be covered by this. And you will be seeing later on the next sample probe will be nearby this star wheel so that the rest of the location will be covered by the second one. So it will be a hybrid responsibility. One part is directly related to the turntable. The second particle counter we will see later on. It will be responsible for the partial needles, as well as on the other side, it will be responsible for the outside of the turntable. So this is 2 responsibilities for one device based on the risk. So next one will be the needle location. So let's take a look at a little bit closer. So as I said, the first particle counter that I will be initiating on the left side of the needles will be covering the partial area as well as the outside of the turntable, while the second particle counter that I will be included on the right side of my system will be covering the partial needles here, as well as the stopper bowl and stopper activities. Reason here, I can easily put one particle counter right in the middle where my laser pointer is located now. However, my operator, when they are using this location, they will be entering with their 2 hands through the glove, and the gloves will be on top of my particle counter. So each and every time while they are doing this activity, all the particles shedded from the gloves or the turbulence caused by the turbulence will give me the high count. So each and every time I'll be going back and giving my audit trail saying that, okay, my alarm audits, I have an action here, I will be exceeding my alarm limit because of this viable location, microbiological activity location changes. So in order to avoid this, I will be placing 2 particle counters. The first one on the left side will be helping me to cover outside of turntable as well as the partial needles. And the second one will also covering the stopper bowl and the partial needles again. And keep in mind, knowing your operation is critical. These needles, while you are making the filling in this location, they're going from one side and to another side, which means they're not steady, they're not single location needles. They'll be moving from right side to the left. That's why mock-up studies are quite critical in order to define the right locations. So you will be able to measure each and every location thanks to the system design, which is exact size and dimension of your filling line. So in our mock-up study here, we will be able to cover 6 of these needles with the left side, while another 6 or 5 of them will be covered by the particle counter on the right side. So after this location, you will be seeing our after stoppering point. As you can see here, stopper ball will be located in this point where I have my second, third particle counter in this location, but still I will be having the other particle counter because my product will be semi-stoppered. It's not a completely stoppered where we will be sending it into the cupping station. In fact, we will be using these semi-stoppers where we will be sending this item to the lyophilization line. Next one is making these mock-up study testing. Your operator should be able to handle and be able to reach out these microbiological sampling units. Particle counter locations are not as critical as this accessibility because making cleanings or maintenance will be outside of this production area, production time frame. But during this production, you will be able to reach out these impactor heads in order to change your agar plate so that your operator can easily access into this location. So the distance from the gloves has to be defined based on this information. For particle counters, however, you have to make your particle counter isokinetic probe height based on the product that you will be using. If you are using a certain product, you have to mention each and every vials or ampules that you will be filling in this line so that the highest point will be defined based on this information. Otherwise, you may be using very small vials and sampling at a very high location so that your distance from upside to down will be more than 30 centimeters. In general, we're trying to be within 10-15 centimeters away from the neck of each vials. So keep in mind, the smallest vial will be your highest distance, while you will be able to get a shorter distance with the bigger vials. But again, if your change part is supporting a very different size of vials, you have to verify that none of them are within outside of this 30 centimeter, plus none of them will be above your particle counter isokinetic probe. So once you finalize your system design completely, let's take a look at it first. That's my system design as a wraps. So when I have my operators around this machine, for example, I'll be giving you this turntable example already, but when we send this unit out, it goes directly to the capping station or can go directly to this left and right lyophilization system thanks to these mobile loading, semi-automatic loading devices. So knowing the entire system and seeing it one picture is critical in order to define where to sample and how to sample. And your system, once it starts running, you will be able to show your operators the alarm limits based on an alarm limits, this color coding, because we don't want operators to spend a lot of time in order to see the data, verify it with the limit, whether if it's exceeding the alarm or exceeding the action limit. So operators will see just the color coding. If it is green all the way, then they will be safe. If it's red all the way, then there's an issue in more than one location. Or in some cases, the system will show you a partial green areas, partial red or yellow areas where the operator can take the necessary actions during production. But after production, based on the data you collect, you will be defined whether you will take corrective actions or not. depending on the information that you collect from your operator. For example, there's a while breakage, so you open up the system with the you enter the system through the glows. So your glows were over the particle counters. That's why you get a high count, only one time issue, then you'll be safe. But maybe there are things that you don't know anything about it, just pop up from the system, then you have to investigate. But keep in mind, never ever stop your system with the data you collect without making a proper analysis. This will create another level of issues, because stopping the entire area means that you will be keeping your vials open to the ambient air. If there is an issue, you will have it worse, so that the production will be terminated. But you can keep going on, you can keep doing production, because the decision will be made afterwards. Otherwise, things will get worse if you stop your line with each and every alarms that you are getting from the particle monitoring system. Some of these alarms are very well known with the operators, so you don't have to worry and you don't have to stop your production line. So that was the system that we designed. As you can see, we have the particle counters located and microbiological air samplers, active air samplers located into final system as a drawings. This was our pre-installation. Let's take a look at how we installed the entire system. Remember this area? We have our needles here, and we have one on this left side, which is covering our turntable, as well as the left side of my needles. And I have other one in this corner on my right side. Then this part is also covering the partial my needles on the right, as well as the stopper bowl mechanism. And I have these active and passive Petri dish holders where I will be maintaining them during production without having my gloves over the line and over the particle counters. That's why I have a very suitable location for this. While the operator is making necessary changes, they're not putting their gloves on top of the production line, the open products, as well as not on top of the particle counters. So take a look at this location again. I have these microbiological sampling head on my right, so that the operator can easily access with these two ports. And I have my particle counter here, where I will be able to collect all the risk locations on my turntable within 30 centimeters distance. As you see here, from the design all the way to the final, from mock-up all the way to the final design, I have my location here as a particle counter and microbiological sampling head at the right corner, so that I'll be covering viable and non-viable particle monitoring system. So take a look at the picture on the right on my mock-up, and my final installation here. I am within between 30 centimeters away. I'm seeing the partial needles here on my system. So this is part of our post-installation, so that we are going to show you the detailed information, and all this information goes directly to the risk document where we be developed after system installation. So as you can see here, my 30 centimeter almost covering 6 of my 8 needles, and the second part on the right side is covering almost another 5, so that there is no gap between these two locations. There is no gap due to the movement of our needles. So the risk document that we prepared, the post-risk assessment, also includes all this information with the pictures, so that you verify that the system was designed and the risk was captured and addressed based on your system design. So this is how we are in general making the system design, where you can easily apply to your current systems. So why we are doing clean room monitoring? The potential benefits for the monitorings are the fastest response. Fastest response is not limited with the operator's response to the system, but the collecting data is critical here. We're seeing in some cases, since we are using 1 CFM devices, which is 28.3 liters, some of the companies are waiting up to 36 minutes in order to get 1 cubic meter of air to be sampled so that they can reach out the GMP Annex 1 table or ISO 14644-1 table limits. That's a very wrong statement. Best way is to get the fastest response and divide these numbers into the certain liters per minute so that you will be getting the action or alarm conditions in every minute. Some people say the 5 micron limit is 20, so you cannot divide it to 36. That's why you have to get a certain minutes, like 9 minutes, 36 minutes, whatsoever, in order to see these limits. However, GMP itself says when you are using the monitoring requirements, you don't have to follow directly to the table limits, but you can make your own limits. For example, for monitoring purpose, 5 micron is an early indication of our alarm limit. So set up 1 as a, for example, warning limit, 2 as an action limit, because in any case, in every minute, if you are taking these 1 or 2 samples, then you will be in danger. And the total of 36 minutes or end of your production, you can say, okay, I collected this much of an air. So for classification purpose, you can make your own calculation to see whether you finalized your production under ISO class 5 or GMP grade A environment. This is an after production decision, but during production, you have to make sure that you are taking the fastest response possible. And ability to develop trends from the data over time. So what you collect is data. How you use and how you make it reasonable as a knowledge, insight, and the wisdom, which I will be showing you later on, is the value of your data. Otherwise, collecting the numbers doesn't make any sense. Integration of data for multiple instruments is critical because one location doesn't make any sense while you will be looking out 0.5, 1, and 5 micron in overall production area. And enhanced knowledge of installation and process, which allows for more effective risk assessment, like I introduced you from the beginning of this presentation. From day first, you have to know what will be the risk for your system and how your system is handling this risk and where is the highest risk possible in your production line. Also within the clean room, not limited with particle monitoring, but also for microbiological sampling. So improved control of operational cost and product losses through this maintaining your monitoring system. Let's take a look at this data analysis. I give this example several times on our previous presentations, but I think that's critical to know what is data all the way to the wisdom in order to fulfill your monitoring requirements. Most of the customer, what we are seeing is they're collecting data, but they don't know what this data means. They don't know what the value of this data. For example, I'm seeing the numbers here, 0, 0, 90, 21, 66, whatsoever. What is this? Is it per minute particle data or meter cube particle data or the colony forming units for the active air sampling or just a data where we collect, for example, maybe these numbers, when you take them all together, this is our office phone number. So in order to make sure that these numbers are valuable for us, we need to convert these numbers into the data to the information. From data to information, we need to know the date and time, how many minutes we do the sampling, and where we do the sampling, and what is this. Now we know that this is the particle count with every 1 CFM device every minute giving us these 1 feet cube of data with the numbers of particles in each and every of these items. When we move it into the knowledge, then we are moving it into these value with the alarm conditions, which means, okay, this knowledge tells us there are warning and alarm conditions on my system based on these warning and alarm limits that I mentioned. So now this has become a knowledge. Let's take a look at insight. For insight, we know that within this certain time frame, we have an issue at the warning level on turntable, as well as an alarm conditions on this turntable. But still, these two ends are not matching each other yet, because we don't know what happened exactly during this period of time. So in order to see this, we have to go back into our alarm acknowledgement entry, which is known as an event log. So now I know that there is a one-time independent issue, which was a while breakage. There is an operator intervention, and this is not continuous issue. And as GMP stated, this is a one-time peak value for me. So after production, I don't have to investigate more on this because I know that my operator entered to the area with the glows so that this creates a turbulent. Then this turbulent conditions gives us a high particle count. However, this wasn't continue after this 1 minute sampling so that I don't have to investigate more. This is the wisdom. Imagine if you use this data only and decided to stop your production line immediately, then these numbers, these 40 particles, will become thousands of particles in the next minutes. Every minute you will start seeing thousands of data because the steady movement of your production line stopped immediately and the entire production area become turbulent for a certain period of time, and it may cause a different issues to the production, which is unknown to the operator anymore because operator only knows there was a wild breakage and he intervened with the system. But since we stopped the entire production line, we don't know what was the other burden we gave to the production line in terms of viable and non-viable contamination. That's why this wisdom level is enough for us to make a decision that there's nothing wrong with the system. There are other metrics, for example, microbiological activity in active and passive petries. So we will be verifying this information and we will be releasing our product without having any doubt after having these microbiological data. That's why seeing your data from day first all the way to the end is critical. From data to the wisdom is critical in order to see with the final recordings. Trending is also same. In order to see your trending data, you have to verify each and every location and overall system performance with the trends. Otherwise, you will get notified from your system after your limits are exceeded. But if you check your trends in a certain period of time with your monitoring system without reaching out of your limits, then you will get notified because you will be seeing the slope of your data going high even within the limits. So that's all for today's presentation, and I'll be checking for the questions section. If you have any questions, feel free to type them in so that I can answer. Also, you can send me an email through the mail address that's shown on my screen now, or through the social media like LinkedIn. Let me check the questions now. Okay, one question is about the location, number of locations to be sampled for the monitoring purpose. How you do the calculation? What are the connections between the area, meter square or foot square of your area versus the number of samples? Not like the classification. You know, the classification, we have the table A1 where we are checking the number of locations to be sampled. Not like the classification. the location to be sampled for monitoring is directly related to the number of risk locations. For example, you have a shearing filling machine, which is a complete robotic system design, and a very small area. You may need only one particle locations to be monitored based on your risk assessment. But the same size eye drop system with a lot of operator interventions, you may need 3 or 4 locations based on your risk assessment. Even the size or even the design of the system is quite similar. The number of locations to be sampled for monitoring will be decided by the risk assessment, not by the area of your production line. Or, for example, the huge vial systems sometimes requires 2 or 3 locations, since it's completely for the fully stoppered systems. But in some cases, very small lines with the lyophilization processes requires more than 10 locations, all the way from turntable after deparenization tunnel to the lyophilization location, including the passage conveyors or the conveyors itself. So it's all about the risk assessment. So one another question was about the clean room monitoring for viable and non-viable. And this question is about the viable, how many locations you're going to sample for the viable monitoring. Especially for the viable monitoring systems, these locations to be defined as like we're doing for the particle monitoring systems. In general, we are trying to place one sample location for viable as well as non-viable. So because the risk value is almost the same for 2 locations, that's why you can make an identification between these 2 locations, these 2 parameters. So if you are placing viable sampling, you have to sample one non-viable monitoring location as well. In some cases, for example, capping stations, particle monitoring systems, due to the product nature, since you have a lot of aluminum flakes all around the surface, you may consider having an extra non-viable monitoring locations, which is a microbiological activity locations, in order to ensure that these particles that you are seeing on your monitoring system is not directly related to microbiological activity, but the product itself. Okay, for the other questions, please feel free to send an email. We'll be concluding our webinar today. Thank you for your time and hope to see you on our next webinar.